Hey everyone, welcome back to my channel. So today we are going to learn about the use of population and sample in the real world industry applications. So in our previous video we learned about that what is population sample and what are the different kind of sampling strategies. So in this case we will go through one by one example and we will figure out that how sampling is used in the real world scenario. So the first example is smartphone launch survey. So for example, if a smartphone manufacturer company is planning to launch a smartphone in India, okay, in that case, first of all, they need to figure out that how many users are using the smartphone in India. So they figure out that there are approximately 400 million people and they lie in the age group of 18 to 45. Now in this case they cannot study all the people, that is not possible. Okay, so what they did is they selected 5,000 users from different states, income groups and age brackets. So here you can see the selection criteria, that is different states, income groups and age bracket. Okay, so we have studied about this sampling method in our previous video, that is called the stratified random sampling. So in this sampling the entire group, okay, entire population is divided into the multiple groups, okay, and based on their characteristics. So that's why we are using the stratified random sampling. Now they collect the data, okay, now they selected 5,000 users and they collect different kind of data from those users. For example, the preferred features, that means what kind of features the user prefer in their smartphone. The second is the price sensitivity. So how much price they are going to pay, okay, how much price they prefer to pay for a smartphone. Then third one is a brand loyalty. So that means whether the users will switch to the new phone or they switch to the new existing brand, okay, not new phone but a new brand. And the fourth one is the usage pattern, that means how much hours they spend in on the social media like Instagram, Facebook, okay, their usage pattern on the smartphone. So based on this data collected, the company get insights to design their product features and means select or decide their pricing strategy. The second one is a biscuit factory quality control. Okay, so for example, a food manufacturing company is producing 1 million biscuit daily. Okay, and they want to ensure that there is a proper quality check of all the biscuits. In that case, the population parameter is 1 million biscuits produced in a day and they cannot check all the biscuits. So what they did is they select 500 biscuit every hour and perform the test on them. Okay, and the total biscuits they test daily, that is a 4,000 per day. Now in this case they use the systematic sampling method. Okay, so for example, on the conveyor belt what they do is they select every 250th biscuit and on that particular biscuit they perform certain tests like weight, checking the weight of the biscuit, the checking the texture of the biscuit, the moisture content and the breakability of the biscuit. Okay, so in that case they ensures the quality while maintaining the profitability. So that's how you can see this, how sampling is used even in the industries, in the manufacturing or the production line. The third one is a clinical drug trial. Okay, so for example, a pharmaceutical company has developed a new diabetes medication, and first after developing the new medication they have to test that on the people. Okay, so there are, for example, approximate 500 million peoples having the diabetes all over the world, so they cannot perform test on all the people. So in that case they need the sample patients, okay, sample data. Okay, so they select 10,000 patients across 50 hospitals in the multiple countries, and the duration of the trial is a 2-year clinical trial. Okay, 2 years. So after selecting those patients then they uh, collect different parameters from the patients, that is the blood sugar levels, glucose level and etc. And based on those parameter collected they observe the side effects and effectiveness in the patient. So if the patient if the selected sample, okay, if the 80% of patient shows the effectiveness, that means drug is approved for the entire population. So you can understand that how sample data is used, okay, to get the insights about the population. So now we are going to study about how population and samples are used in the machine learning. So this is a very important and critical part to build the machine learning models that perform really well. Okay. So coming to the, we will see three different examples. So let me repeat again. So population is machine learning. In machine learning is the all possible data point that exist for your problem. Okay, that exists till now for your problem. So we will see one example of the image classification. So now, for example, suppose you have to train the machine learning model. Okay. So based on that, if you give the photo of certain cat, okay, certain species of the cat, it can predict that what kind of species of the cat is it is. Okay, and it can like give more info about that cat. Okay, so for example, here the population is the all possible photos of the cats that have been or will ever be taken till now, okay, that exists till now in the world. So as we know that we cannot get the all population data, so in this case we take a help of the sample data, that is a training data. So for example, so you collect 10,000 cat images, okay, from the internet. Now you are going to train the model, okay, on these samples, and this model should be trained in such a way that it should work for the entire population. That is, suppose in the future a new photo of cat comes, okay, so it can also predict well. So here the challenge is that your model is trained on the sample data, okay, but it must perform well on the unseen data or the pictures that will be clicked in the future. So in this case, that we know that we have studied about the sampling techniques in the previous video. So these techniques help us to get the data, like it should be a diverse, okay, in that case, so that it can perform well on the unseen data. Now coming to the second example, that is the spam email detection. So suppose you have to train the machine learning model which can detect whether the email is spam or not. So in this case, the population is the all the emails that exist in the world till now. Okay, so you cannot collect those emails, you cannot get those population data that may be in billions or trillions, so you cannot get those data. So okay, so in that case you took the 50,000 label emails, that is spam or not spam, okay, and out of that you collected only the 40,000 emails to train the machine learning model, and the remaining 10,000 will be used to evaluate the model. Okay, so now once you train the machine learning model, the model must work on the future emails, that will be the millions of emails. Okay, so for example, if the model, if suppose if you receive the mail that is spam and it goes into not spam, that means your sample data is biased. So for example, you collected the sample data, the email, the label emails only from the year 2020. Okay, so that means your data is biased. So in this case, your data should be, the sample should be a diverse sample that could be from different years, like starting from like uh, uh, 2005 to like till 2026. Okay, so it's the sample should contain the diverse data from for all the years. So in that case the model can perform well. Now coming to the second example, that is the disease diagnosis. So in this case, you have to train the machine learning model in such a way that it can diagnose, okay, diagnose the disease from the patient data that is given to the model. So for example, here the population is all the patient data that is collected till now in the world, so you cannot get that. In that case, you choose the sample data and you collected for example, 5,000 patient records from only three different hospitals. Now, the problem is that you collected only from the urban hospitals, that is in one country. So in that case, the risk can be the model may not work for the rural populations or the other countries. Okay. So here the solution is that you should collect the diverse data. Okay. And the samples. Okay. That should include from different demographics, geographics, and the healthcare settings. So my purpose is in this video, my purpose is to teach you that how samples plays important role in order to train the machine learning data. Now, we will study the common mistakes to avoid when you are going to train the machine learning model. The first mistake is the sample size is too small. Okay. So for example, the company has the 100K customers and it surveys only the 20 people. Okay. So here the 20 people are too small to represent the 100K customers. So in the previous video, we have studied that the sample must be in such a way that it should represent the entire population. Okay. So in this case, if you train the model with this limited amount of data, then the results will be unreliable and may not reflect the true characteristics of the entire population. So better approach is for larger population, a large sample size should provide the more reliable result, and the sample should be collected in such a way that it includes like diverse. Okay, it should be diverse. It includes from the different demographics, geographics, etc. Okay. Now coming to the second mistake, that is a voluntary response bias. So for example, here the scenario is a website post survey, okay, to rate their services and it wait for the responses. So here the problem is like only very satisfied people or very angry customer respond, okay, and average customers ignored it. So if you are going to train the machine learning model on this data, that is from the very satisfied people or the very angry customers, okay, in that case you miss the data from the average customers, and your model may get the extreme opinions, not the typical ones. So the better approach is here, you should randomly select the customers and actively request their feedback. Now coming to the third mistake, that is confusing the sample with the population. So for example, a student studies the 100 data points and incorrectly assume it represents everyone. Like the student consider this 100 data points as a population data. So the problem is like unless those 100 points are the entire group you care about, it just a sample. Okay. So that means, for example, if you are only studying only those 100 points, okay, and you have to train the model like it should, and those 100 points are the maximum possible points that could ever exist. Okay. That means that data is a population, but if those 100 points represent a larger group, then that data is a sample, not a population. So the impact is that treating a sample as a population lead to incorrect interpretations and conclusion. So this is the main mistake one should avoid. And uh, in my experience, you can never get a population data. You have to collect the sample data. Yeah, maybe the sample data size can be very large, but you cannot get the exact population data. Now, the fourth mistake is ignoring the non-response. So, for example, a mail, uh, a company mails, okay, for a survey to 1,000 peoples, and after that, only 200 people respond, okay, and you analyze, and the company analyze this only the response from the 200 people, and the problem is the 800 people who didn't respond might be different, okay, different kind of people, systematically different. Example, they can be a busy professional, okay, may not respond, okay, and the people who respond may be the retired people, okay. So here the solution is that you should follow up with the non-responder or acknowledge the limitation. Okay, when you are training the model, you should acknowledge the limitation. So these are the major mistakes you should avoid, okay, while training the machine learning model. And these mistakes are generally for when you collect the sample data. So congratulations to all of you. You have completed the comprehensive guide to population and sample data. And let me repeat it once again, that what you have learned so far. Okay, so we have studied about the core concept of population and sample, then parameters versus statistics. That means what is the population and what is the sample. Then we studied that why sampling is necessary and powerful, then how we can avoid the bias, then the real world applications of population and sampling and its connection with the machine learning. So I know that this information, okay, that I gave you earlier, okay, this is only the theoretical, but believe me, in the future, when you are going to train the machine learning model, this piece of information will work as a prerequisite when you are going to train the model, and it will be very helpful for you. Okay, so you don't have to go back and forth. And here the key insight is that I have to tell you that nowadays in the cloud they are providing you the ready-made algorithms. Okay, so only thing that main you have to focus on is the sample data. So the good data collection is as important as a good algorithm. That is a key insight. And keep learning these foundational concepts. Okay, these are the foundational concepts of the statistics and ML. And yeah, thank you.